Hey, good morning. My name's Ayush. Today my topic is supervised learning for robust hand posture classifications from marker-based motion capture data under marker inclusion and cross-user variability. So this dissertation looks at how computers can recognize hand postures using motion data capture and how to make this work reliably for missing data and different people. So it's an introduction. Hand posture recognizes means teaching a computer to understand hand shapes. It helps in sign language, gaming, VR, medical recovery, controlling robots, and many more. This study uses small reflecting markers tracked by cameras to record hand movement in 3D. This is a problem statement. There are two big problems in this. First, sometimes a marker gets hidden and its data is lost, called occlusion. Second, everyone's hands are a little different, so a model trained on some people may not work well for a new person. Most past studies only solve one of these problems, but this study solves together. Research aim and objectives. The goal of this research is to build and compare machine learning and deep learning models, which also testing three ways to fill in missing markers and data and checking how well models works on new users. So is the research questions we have three main research questions we have guide this research. How do machine learning and deep learning models compare? Which method for missing filling data works best? And which combination is best for real world use? So literature review and research gap. Earlier, search studies hand gesture using cameras or muscle sensors, but not much using marker-based motion capture. No one had compared eight different models, three ways of filling missing data, and cross-user testing altogether. So this is the gap, and this study fills. Methodology dataset. This data comes from public data set with 12 people wearing 11 markers on their hand. 5 hand postures were recorded, giving over 78,000 records. Some marker values are missing because the camera could not see them. So this is the methodology approach. The methodology approach has three steps. First, the missing values are filled in three ways. Second, eight models are trained, tested for simple traditional models and four deep learning models. Third, two new test users, one data person is left out of testing while the rest trains the model repeated for every person. Result standard evaluation. In normal testing, gradient boosting was the best model, reaching over 93% accuracy with simple mean data filling of missing data. Deep learning models like LMP did reasonably well, but others like CNN and CapsNet struggled and performed poorly on this type of data. So this is a results cross user LOU evaluation. When tested on completely new users, every model performance dropped a lot in gradient boosting fell from about 93 to 72% as you can see. This shows that people are genuinely different and building a data system that works for everyone is much harder than it looks. So discussion key finding. Simple tree based models beat complex deep learning models here, but because the data set is small and made of plain numbers, not images. Surprisingly, the easiest method for filling missing data, the mean, worked best. Overall, gradient boosting with the mean filling was the most accurate and reliable choice. So limitations, this is the limitations. This study has some limits. Missing markers were recorded as zero instead of truly blank, which may be affected the filling methods. Only a small balanced part of the data was used for training. Deep learning models might need much more data to perform well. Only 12 users were tested. So this is the conclusion of future work. In future, in conclusion, we can say we can gradient boosting with mean based filling of missing data gave the best and most dependable results. For the future, using better recorded missing data, larger data sets, and testing with more diverse users outside the lab could make this system even stronger. So this is a reference I took for presentation. This is all the on the screen. This is a reference all. Thank you very much. This is my code. You can see this is all code. This is the all coding which can I use that. Thank you. Thank you very much.